Chapter 2, Lesson 5 in Advanced Algebra, and we're going to graph these absolute value equations using two linear equations. So in order to do that, we need to isolate this absolute value symbol first, and then we will use the definition of absolute value to come up with the two linear equations, and then we'll graph those. Now, the first thing we want to do before we start is to look that in front of the absolute value sign, in front of the absolute value, we have a negative sign. Now that tells me that my absolute value V graph is going to open down. So a negative sign opens down. So we want to keep that in mind. So I want to solve for this absolute value symbol. So I'm going to move the absolute value, the entire thing, to the other side, making it positive for now to solve it. So I'm going to get the absolute value of 3x plus 1, then plus y is equal to 6. And then I'm going to move the y over to isolate the absolute value. So that's going to give me 6 minus y. And now that I have this solved for the absolute value, I can have determine my two linear equations. So remember, I'm going to have 3x plus 1 is equal to 6 minus y. That's one equation. And then 3x plus 1 is going to equal the opposite of 6 minus y. That's the definition of absolute value. So then we'll go ahead and solve this now for y. So now I'm going to switch everything around. I'm going to move this y over to the other side, making it positive. And I'm going to move the 3x over to the other side, making it negative. And I'm going to move the 1 over by subtracting 1. So that's going to be 6 minus 1, or 5. So one of my equations is y equals negative 3x plus 5. The other equation, then, I'm going to solve this. So I need to remove the absolute value first. No, the parentheses, excuse me. So I'm going to distribute that negative sign. And then I'm going to move the 6 over, solving for y. So that's going to give me 3x. And then I'm going to have 6 plus 1 is 7 is equal to y. So if I just use the symmetric property and put that in slope-intercept form. So I have my two equations for my two lines. So I'm going to go ahead and graph those. Now I have a y-intercept of 7 for this one. So again, well, I have enough tick marks here, so I have my scale on here, so I'm going to go ahead and graph this. So the first equation has a y-intercept of 5. So I'm going to go up to 5. Okay, so there's my y-intercept. And then my slope is negative 3. So that's going to go down 3 and then over 1. So I have my 2 points. So then I want to go ahead and graph my line. And again, we're going to use a dotted line. Okay, because only part of this line is going to be my actual absolute value graph. All right. Then I'm going to graph the second linear equation. So I have a y-intercept of 7. Let's see, it's 4, 5, 6, 7 right here. And then I have a slope of positive 3. So that's going to go up 3, 1, 2, 3, and over 1. So that's about right here. So then I'm going to go ahead and graph that linear equation. So that's going to be something like that. Okay, so I have my two linear equations graphed. Now remember, we started off by noticing that in the original equation, the absolute value has a negative sign in front. So that means that my absolute value graph is going to open down. So I have my vertex right here. Okay, and I want to label that vertex. And you remember, if we're not able to determine it from our graph, remember we can do the opposite of b, which here is 1, over m, okay, which is 3. So negative 1/3 is my x-coordinate. And then the y value is the c, which here is 6. So negative 1/3, 6 is my vertex. That's the coordinate of this point right here. And then again, we know that it opens down, so we're going to then, from our vertex, do the raise from going down. So here's my vertex, so this is going to go this way, and this one's going to go this way. So this would then be the graph of my absolute value function. And then again, I want to label this, so I put the original equation on here, negative absolute value 3x plus 1. And so that would be the graph of this equation. And if I have put this on here, you'll notice that it's pretty close. Okay. All right, so let's do another one. So here I have the equation y equals the absolute value of 4x plus 2. And in this case, the absolute value is already isolated, so I can go ahead and just write my two equations. So I'm going to have 4x plus 2 is equal to y, and 4x plus 2 is equal to the opposite of y. So this equation is already in slope-intercept form, so I'm just going to write it like that. Then I'm going to have to divide by a negative sign, so that's going to change the sign of everything. So that's going to be negative 4x minus 2. So I have my two equations, so we'll go ahead and graph each one of those. So here I have a intercept of 2, y-intercept of 2, and then a slope of 4. So I go up 4 from the intercept, 1, 2, 3, 4, and over 1. So that's about right here. And then I'll go ahead and graph that. Do this. Okay, so there's my first equation graphed. And then I'm going to graph the second equation where a y-intercept here of negative 2. So here's my y-intercept. And a slope of negative 4. So that's down 4. 1, 2, 3, 4, and then over 1. So I have my 2 points. Although that will allow me to graph my second line. Alright, so we have the second line graphed. Then again, we have the vertex is going to be about right here. I need to label that, so I'm going to use the opposite of the b over the m for, so that's going to be negative 1/2 is my x coordinate. And then c here is 0, so that's going to be the coordinate of my vertex. The absolute value is positive, so that means my graph is going to point up. So I go from my vertex then, and the rays are going to go up. So this will be one ray, this will be the other ray. And so there I have my absolute value graphed using the two linear equations. I'll label that. And that's what our graph should look like. And again, I'll do that. Okay, so here's one where we have an absolute value, minus 3. I'll notice that the absolute value is positive, so my graph will open up. So I need to isolate the absolute value, so I'm going to add the 3 to the other side. So that's going to give me the absolute value of 3x plus 4 is equal to y plus 3, adding 3 to both sides. Now that the absolute value is by itself, I can write my two equations. So I have the absolute, or 3/2 x plus 4 is equal to y plus 3. And then I'm going to have 3/2 plus 4 is equal to the opposite of y plus 3. So having my two equations, I simply want to solve for y, so I'm going to subtract 3 from both sides. So y is going to be equal to 3/2 x, and then subtracting 3 from 4, that's going to be plus 1. So there's one of my equations. So I need to, this is 3/2 x over here, I didn't write that, plus 4. So I'm going to take the opposite of y and the opposite of 3. I'm going to add 3 to both sides. I'm going to move this over this way, so I hope you can see this. 3/2 x, and then adding 3 to both sides is plus 7 is equal to negative y. Now I need to solve for y, so I'm going to have to change the sign of everything. And so now I have my second equation. So I have my two equations, so now I simply graph those linear equations. So we'll graph this one first. We have a y-intercept of 1, and then from there I have a slope of 3, so 3/2, excuse me. So that's a rise of 3, 1, 2, 3, and a run of 2. So that gives me a second point about right there. So then I'm going to go ahead and graph, or draw my line in there. So this is going to be something like this. And then my second linear equation here has a y-intercept of negative 7, so it's down 7. 1, 2, 3, 4, 5, 6, and 7. There's my y-intercept. And from there I have a slope of negative 3/2, so that was going to be down 3 and over 2. So that gives me my second line looking over here, about like this. Okay. So now we need to, or we have the vertex is at the intersection point. I need to label that vertex, so I'm going to use the opposite of the b. Let's see, where can I do that? I'm going to erase some of this up here so I have some room. So the vertex, remember, is the opposite of this b value 4 over or divided by the m, that's 3/2. So that means negative 4 times the reciprocal. So that's going to be -8/3 is my x-coordinate. And then the y-coordinate is this value out here, which is -3. So there's my vertex. And again, the absolute value is positive, so that means the absolute value graph is going to open up. So I have my vertex, whoops, didn't want that screen. Opens up, so from the vertex it's going to open up, so it's going to go this way. Let me redo that one. It's going to open up this way. That's positive, so it opens up. So I have my graph of my absolute value looking like this, and then I'll go ahead and put my equation in here. Absolute value of 3/2 x plus 4 and then -3. So this should be what the graph of our absolute value function looks like. You see I'm pretty close. Okay, the last example I'll do in here, again, I notice that the absolute value is negative, so I know that my absolute value graph is going to open down. I'm going to solve or isolate the absolute value. Now I'd like it to be positive, so I'm going to move that to the other side as my first step. So it's going to be absolute value plus 1. And then I'm going to move the y over to the other side so that my absolute value is by itself. So I have it isolated, so I can write my two equations. X plus 1 is equal to 2 minus y. And then my second equation is x plus 1 is equal to the opposite of 2 minus y. And then I'll solve these for y. So y needs to be positive, so I'm going to move that over to here to make it positive. I'm going to move the x over here, and I'm going to subtract 1 over here. So there's my first equation. Then on the second one, I'm going to remove the parentheses by distributing the negative sign. That should be -2 plus y. And then I'm going to solve for y, so I'm going to add 2 to both sides. So that's going to equal x plus 3. So I have my two equations, so I'm going to go ahead and graph those. So this one has a y-intercept of 1 and a slope of -1, so it's down 1 and over 1. So I have my first line that I can go ahead and graph. Get my dotted line here. There we go. Okay, so this is going to be about like that. And then I have my second equation here, which is x plus 3, so that's a y-intercept of 3. Let's see, 1, 2, 3. And a slope of +1, so it's up 1 and over 1 this way. Well, let's see, +3, then up 1, over 1 is about right here. So I then have my 2 points and I graph my equation this way. Now, as I look at the original equation, I notice that the absolute value is negative, so I know it's going to open down. So I have my vertex, and I need to label my vertex. So again, I'm going to erase this. I need to determine that, so I'm going to use the opposite of the b, which is 1, over the m, which is 1. So the x-coordinate is -1. And then the y-coordinate is the c value. Now the c value is normally out here on the right, but it's just in front here. That's a +2. I could move that over here and it'd be the same. So that's going to be a +2 for my vertex. And because my graph is, or that absolute value has a negative sign in front, I know it's going to open down, so I'm going to use the bottom half of these lines, or the lines that go down this way, as the rays for my absolute value. So then I have my absolute value graphed. And then again, I want to label this, so I'm going to put the equation that I began with right here, and then I have the absolute value graphed. Again.